Hello and welcome everybody to a new Houdini tutorial. In this tutorial, we are going to take a look at instancing in Solaris. This tutorial has two parts. In the first part, we are going to create this setup here. So right on top here, I have three USD objects. These are animated. They have a very simple animation on them. And we will use the instancer here to instance these objects onto this model here. And then we will change some attributes. We can change the color, we can change the distribution, we can change the scale. And in the second part, I will show you how you can retime instances directly in Solaris. Right now you see that they are all animating at the same time. But in the next part, in part number 2, I will show you how to retime these instances and distribute this however you want using some attributes. I open up a new scene and I am now already in Solaris here. But before I do anything, I will just save my file to the right path here. So let's save this quickly here. Okay. And now I want to load in my animated USD files. So let's go to add in a reference node. And here we can choose a file and we will use the object number 1. By the way, if you want to follow along, then you can of course download the project with all the assets on Patreon, but it's actually not really necessary to follow along. You can just sit back and watch that. You saw that I had this little error here, and maybe this was a little bit too fast. Let me go back here. Sometimes if you just use this $hip path, then it will create an error. And then you have to put this path under these quotation marks here, and then it should work. As you see, now it works. And if I scroll my timeline, you see I have my great animation here. This very low poly thing here just animating on and rotating a little bit. By the way, the workflow that I show you in this tutorial series is actually not really for something like that. This is just an example. I want to keep it simple. But usually I would use this workflow with these animated USDs for more complex things like growing plants or characters with a walk cycle that you want to instance and offset, something like this. If you only have these very simple transformations like scale and rotation, there's definitely a better way to do that than this USD workflow, but I use this just as an example. So let's set this up. Let's first of all give this node a name, and let's say this is our object number 01, and I also want to give it a path. So we will just put it into a geo directory and then use the name of the node to specify the name of my object. And you see now I have this hierarchy here, and that's fine. Let's bring in the second one by just duplicating the first one. And now I think my viewport has a problem. So let's go to the viewport and reset it. Yep. And I will just change the path here to object number 2. Everything else is the same. Now you see I have my second object in here. And these are really just spheres with a mountain node, very low poly spheres, and then a simple animation over 40 frames. Now let's bring in object number 3. Again, we just change this number here and we have object number 3. It's also very similar. Now we can merge all of these together. And I have all of my objects that I want to use in my scene. Now it's time to set up the instancer. And therefore we bring in an instancer node. And this is actually very similar to the copy to points node. So what you need to use the instancer is you need something to instance on. So you need some point, a point cloud. And if we take a look at the instancer, we have two inputs. The first one is the stage input. The second one is the possible prototype source input. And we want to put our objects into the possible prototype source input. But by default, this doesn't do anything because it still has no points to copy or instance our objects onto. So if you take a look here at the target points, that's probably the most important setting here. There are a few options where the location of your source points can be. It can be in an internal SOP, an external SOP, and you can also choose the first imports primitives or points here. In my case, I want to use the internal SOP, and that means that you just can enter the instancer by double-clicking. Now you are in a SOP context, in a geometry context, and you can put in some points here. For example, if I put in a box now, And let's scale it up a little bit. And I go out here, you see what it is now doing. It is instancing my objects onto these 8 points, and they are still animating all at the same time. If you change this to external SOP, then you can specify a SOP path like we are used to. You can just link it to somewhere in your project. And here you can just choose the first input to create some point clouds. But I want to use the internal SOP. Now, I definitely don't want to use this boring cube. So let's go into our instance again and let's delete that. And let's use a file node to bring in this head that I used in the example. So I will just move to my Geo folder here and choose this head BGEO. This is also included in the download if you want to use the same files here. And that's just the standard head that is included in Houdini that I just ran through a few modeling steps, volume modeling, to smooth it out a little bit. And if I would go out of the instancer now, it would instance an object on each of these points. And I think that this is probably a little bit too much. Yeah, 25,000, that's definitely too much. This will get too slow. So instead of doing that, we will use a scatter and align node, and we will just scatter a few points for now, not too many, because otherwise it will get just too slow. For instancing, it's really no problem, but later on, if we do the retiming, then it can get really slow if you have a lot of instances. So we'll keep it a little bit lower for the tutorial. Now let's go to the density settings, and I want to set the coverage to 1 and set the density to 500 for now. So not too many points, but still a few points on here. And if I go out now, you see what I have. Now the instancer is copying or instancing these objects onto these points randomly. You cannot really see this that good. The shapes are different, but also a little bit similar. So let's quickly set up some materials that we really see what's going on here. Therefore, I will just create a material library very quickly. And I will go in here and use material X builder. Call this my object number 1. And I will just set it up very basic here with the color. So let's say the first one is pink. Then we create a second one, object number 2. And let's make this maybe turquoise or something like that. And the third one, we can make it blue. That we can distinguish between these a little bit better, especially when we are dealing with the distribution later on. Now let's just autofill all the materials and let's assign them quickly directly here. Let's make it simple. And here we can go into our instancer now. You see our geo is now inside this prototypes null group here. And now we can just directly drag these over. So let's say object number 1 is this, object number 2, and object number 3. And now you see that we can distinguish between these a little bit better. So how can we control the distribution of these? As I said, by default, it is set to random. And you can see this in the options down here. It's set to random, the prototype index, and you can change the seed here. But of course, we can also control this. And we can control this by using an index attribute. And that's what we want to do. So let's change it to index attribute. Now we have to create an attribute with the name of index. And you want to create this attribute inside your instancer on the point cloud. So let's enter our instancer again. And let's take a look how we can set something like this up. There are, of course, many different options in Houdini to create this kind of an attribute. You could use a wrangle. You could use some attribute create nodes. In my case, I just want to use an attribute WOP because I want an index attribute that is based on a noise. So let's choose point WOP for now. And let's enter this point WOP. As I said, I want to use a noise to create my index attribute. So I will use an anti-alias noise that requires a position input. And for now, I will just plug it into my CD just to take a look at the colors here at the geometry spreadsheet, or at the values, I should say, not at the colors. Right now, it ranges from minus 0.23 to plus 0.24. And I want to have an index attribute that represents the number of objects I have. I have 3 objects, so I need an index attribute that ranges from 0 to 2, and it should be an integer. So let's remap, or let's fit the range of our noise by using a fit range node, and put this in here. And in the first step, I will just specify the value here. So I can just set this up to minus 0.3. That was approximately the range that I had here, and to plus 0.3. I can change this later on, and this will have an influence on my distribution. And for now, I just change this distribution to a number of 0 and 3. And why am I doing that? So if we take a look now at the values that we have here at the color values, they're ranging now between 0.34 and 2.7. Now I want to round this down, and if I put in here a value of 2, so the range of my index attribute, I would get, as a high number, I would get 1.8. And if I round this down, then I'm on 1. I only have 0 and 1s. So this would not work for 3 objects. And that's why I put in 3 here. And now I can round these down using a floor operation. And if I just put this in here and take a look at my values now, I should have values between 0, as you can see here. Then some of them should be at 1, as you can see here. And some of them should be 2. And we can change this distribution by just changing the min and max values here. We could also use a ramp to do that if you prefer. So what you can do, for example, if you prefer to work with a ramp, then we can just say we increase this range a little bit so that we cover more or less the whole range of values of the anti-aliased noise. And then we could just bring in a ramp. The problem of the ramp is that the ramp usually works with values between 0 and 1. So we should do it the following. We should remap this in the first step here to 0 to 1. Then we can use our parameter ramp. So ramp parameter, this one here. And in this case, I want to use a spline ramp, and I put this in here. Now, of course, we have to do another remap because we need to remap the outcome of our ramp to the range of our index attributes. So let's do this. Let's put in a fit range here. And now we can just set this to 0 to 3, from 0 to 1. And if I go out here now and just create one of these linear distributions, oops, like so. Yep. Now we can take a look at our values here. So let's go into our WOP again, and let's take a look at our CDR. And you see we have some 0s, we have some 1s, and we have some 2s. And we can use the ramp to change the distribution. I will show you this in a moment. Now, let me actually promote some attributes here by middle mouse clicking, and I want to promote the frequency, I want to promote the offset, and I want to promote the roughness. That's it. I do not need more here. So now I have to create my index attribute, because right now I'm just feeding this into the CD just to check the values here. But of course I did not create the attribute. So let's bring in a bind export node here to write down our numbers to an export or to an index attribute. So index, and this is an integer. And now we can go out here. And this should be recognized automatically now by our instancer. So if we go out now to the stage level, this should already work. So let's go up one level. Oops, pressing the wrong button here. And you see what is happening now. Now our objects are distributed based on the noise and based on our index attribute. So we can pin this for a moment, this viewport, because then we see what is going on here. And now we can go inside here and change these values a little bit. So now we can play with the distribution. Let's maybe increase the frequency a bit so that we have a few more patches here, like so, not too many, something like that. I want to reduce the roughness a bit. And now I could come in here and change this distribution here on my ramp. As you can see here, if I increase this here, then I lose a lot of my pink ones. So let's do something like that maybe, that there are a few of these. And then I can change it up here. and this will control my blue ones. You see, if I bring this up here, then I get a few more of the blue ones in here. So this way I can now nicely control the distribution of my objects around my head. And again, you can of course change the frequency, and you can of course also offset this. So this way you can create some cool effects. You can also animate these things. Maybe increase the frequency a bit more, something like that. Yep. So this looks nice. Okay. Now, of course, we can also control other things, like the scale, for example, or we could also create colors directly inside our instancer. Let me show you this quickly. So to change the scale with also maybe based on a noise, you could just use an attribute adjust float node here. And these are pretty basic operations here. You're probably familiar with that anyway, but maybe some of you don't know it, so I will just include it here. And we can set it always, so we will set the p-scale attribute always here. And instead of constant, I want to use a noise. And now these are way too big, so we can just change the maximum value to a value of 0.2 or something. Like, let's take a look. Still too much. 0.05. Still too much. That looks a little bit strange. Let's set it to 0.02. These are too small now. 0.04. Yeah, let's go with this for now. And we can set the minimum value to 0.01 so that these are not totally disappearing. And now, of course, you can do everything that you can do with this. You can change the distribution here with this ramp, you know, can create some nice patterns here. You can also change the size of the element, so to make this noise a little bit smaller. That's probably something that is good because the scale of our head is actually quite small. So now we have a bit more of an interesting distribution here. Maybe we set it to 0.25, as you can see now. And now I created a nice variation of sizes on my head. And maybe let's set this to 0. Then some of them are just gone. And of course, you can always change this distribution, as I said, with this ramp here. So if you want to control the fall off here, you can do it like that. Now, I mentioned that you can also create colors. That's of course possible. So you can do exactly the same as I did here now, create a noise attribute, for example. So let's just duplicate this here actually. And we want to set the minimum value to 1 and the maximum value to 0, the maximum value to 1. But I don't want it as a p-scale. I just can name it, let's say, color for now. This is an attribute that is not recognized by Houdini by default, but I can now just use a color node, and say ramp from attribute. We put in the attribute color, and now we cannot see this here because our color is overwritten by our materials. But if I go in here now, and let's just quickly create a second material library. So this is the one for the distribution. So I will just call this distribution to visualize the distribution. And now we create a second one. Let me make this a little bit smaller. And this will be the one that I want to use for the color, to display the color. And now we can go in here into our materials. And instead of setting the base color manually, we can use geometry property value node. And we can take a look at a color value, and it is called display color. So if you're not familiar with Solaris, it has a little bit different names for the variables, for the attributes. And I would recommend that you watch my basic workflow tutorial about Solaris. So you see, I can just import this now. And let's take a look whether this works. I'm not quite sure for now. It is spelled correctly, so it should work. Let's see. I can just copy this node now. Let's go in here, paste it in, and set it to base color here. Now this turns black. Let's see whether this works. I'm not sure. So paste this in here. And now base color. Okay. Good. So the color is not visible now, but maybe if I change it to one of the renderers, maybe the CPU, we will see something. And yet already you can see something. We actually have some color variation in here, but now it's not very obvious because we didn't change it. It is exactly the same noise as the noise that changes our P scale. So let's do that quickly. Let's make this a little bit more interesting. And let's put this out here. And then we can just offset this noise, you know, and now we will see something a little bit more interesting here. And you see that our color noise is actually having an effect on our objects. So you see that this is only working when I switch on one of the renderers, the CPU or the XPU. It should work with both, as you can see here, but it is not working on the Houdini GL. If you want to display the color that is created on the instance point cloud, in your viewport, you would have to change the method. And I didn't talk about this, but there are a few methods on the instancer, how you can actually instance. There is this point instancer that we are using right now, and I will open up my scene graph tree for a moment because this has an influence how this is actually instanced. Right now, it is just copying our 3 original objects onto the points, and you see in my instancer, there are only 3 prototypes here. But if I change this, for example, to reference, first of all, you will see that now my colors are also visible in the viewport. So if you want to, for example, create a flipbook with the colors visible, then you could change it. But you also see that the instancer actually now changed its hierarchy. And now I have all my 500 objects here as instanced objects, as components. And there are a few other options that have different pros and cons and different functionalities. If you want to learn more about this, then please go to the documentation. It's very well explained there. I can definitely not explain it as well. So here you can see, let me show you this where this is. It's exactly here under method. You have all these methods, the point instancer, instanceable reference, that's the one that we are using now, instanceable inherit, and so on. So you can read about these. Okay, so this is basically end of part 1. Let's switch this back to the point instancer. So just to mention this again, we still have our animation in here. And now in part number 2, I will show you how you can offset this animation directly in Solaris. So thank you very much for your support. Thank you very much for watching, and I hope to see you in the next tutorial. Goodbye.